last thing that we spoke about today was the quadratic formula. Sometimes you have to go to an old friend to meet new friends. Okay, so the topic was quadratic formula and the discriminant, and we'll continue this. Within this quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac over 2a. We have two hidden treasures that are there. One of them you know as the axis of symmetry. The axis of symmetry is x equals negative b over 2a, or the opposite of b over 2a. The other is called the discriminant. The discriminant is b squared minus 4ac. That's all of this stuff. That's all of this under the radical sign. That's your discriminant. Okay? And you've seen this before, and you're pretty familiar with this, but you just never knew what it was called and the importance of it. So today you're going to look at the importance of it. In fact, the discriminant helps describe the nature of the roots. Okay? Your roots are your answers when you solve a quadratic. Basically, how many times does this parabola or this quadratic crosses the x-axis? Now, the discriminant helps you set limits as to how many times the parabola crosses the x-axis, or what does that mean. So there are three cases of this. The first case is when your discriminant, b squared minus 4ac, is less than 0. Okay? Well, first think about what type of numbers are less than 0. All right? Those numbers that are less than 0 are negative numbers. So we just talked about negative numbers, and because your discriminant is located under a square root symbol, it's important to note that if the discriminant is negative, then the square root of a negative number is an imaginary number. So when we have this case right here, when b squared minus 4ac is less than 0, our roots are two imaginary or complex roots. Two imaginary or complex roots. What that means is it doesn't touch the x-axis at all. So it may look like this. Okay? Or it may look like this. Okay? It's anything that does not touch the x-axis, does not cross the x-axis, did not touch it. It may get close to it, but it will not touch it. Okay? Our second case, case number 2, is when b squared minus 4ac is equal to 0. Well, if b squared minus 4ac, or our discriminant, equals 0, well, what's the square root of 0? That's 0. And it's only one 0 that we know about. So if your discriminant equals 0, the nature of your roots is that you're going to have one real solution. Okay? In other classes, this is also called a repeated root. Okay? And what this looks like is you have your parabola, it touches and it goes back up at that one point. Okay? Have my parabola, it touches and go back down at one point. It only touches once. And that's your root. That's your solution. Well, we dealt with the negative, and we dealt with when the discriminant equals 0. So the only other thing left is when b squared minus 4ac is greater than 0, or when it's positive. Okay? When b squared minus 4ac is positive, that means the number under the square root is positive. So that allows us to have two real solutions. And what that looks like is it goes down and comes back up. 1, 2. Goes up, comes back down. 1, 2. Okay. Well, of course, we have some examples here. I brought a couple old friends back out from our former quiz here to help us out with the discriminant. So we have f of x equals 4x squared plus 1. Well, just like you did the quadratic equation, or excuse me, the quadratic formula rather, list out what your a is, what your b is, and what your c is. Nothing changes. This is still part of the quadratic formula. So in this case, a is 4. B looks like it's 0, and C is 1. So using the discriminant, b squared minus 4ac, we're going to plug in. So b is 0, so 0 squared minus 4 times 4 times 1. Well, we know 4 times negative 4 is negative 16. Negative 16 times 1 is still negative 16. So our discriminant is negative 16, or it's negative, because it's less than 0. So if we go back, if our discriminant is less than 0, that means we have case 1 going on here. That means you have two imaginary complex roots. Okay. Next problem, we have f of x equals 4x squared minus 1. Again, a equals, b equals, c equals. All right, a equals 4, b equals 0, and c looks like it's negative 1. So let's plug it into our discriminant. B squared minus 4 times a times c, or 4ac. So again, b is 0 squared minus 4 times 4 times negative 1. All right. So we have negative 4 times positive 4, that's negative 16. But that's being multiplied times negative 1, so that's actually positive 16. So in this case, 16 is greater than 0. So if we look back at our cases or our rules here, we have a case 3. When b squared minus 4ac is greater than 0, you have two real solutions. So that's how you describe that. Okay. Down here in the bottom left, you have f of x equals 2x squared minus 32. So a equals, b equals, c equals. A equals 2, b equals 0, and c equals negative 32. So we want to use our discriminant here. So you get b squared minus 4 times a times c. Again, b is 0, so we have 0 squared minus 4 times 2 times negative 32. Okay, so we have negative 4 times 2 is negative 8. Negative 8 times 30, negative 32 is 256. So that's a positive 256. So that means that 256 is greater than 0. And we will have, if we go back to our chart here, we should have two real solutions. And last but not least,